Hello, everyone. Thank you for attending this workshop. My name is Faraz. I'm one of the main organizers. I just wanted to add a quick note that last night you would have received a link to our conference platform that's going to be hosted on a platform called Hopin. If you have not received this, please check your junk mail. We will also be sending out a reminder later today at around 6 o'clock-ish. If you still haven't received it, please once again check your junk mail. You can definitely reach out to us on the app and we'll be able to help you. Without further ado, I'm happy to welcome our hosts of the workshops, and I'll be handing off the controls to them. Over to you.
Thank you very much, Faraz.
No worries.
Thank you. Good afternoon, everyone. Welcome to this workshop, and thank you for joining this workshop. We are very happy to be here, although virtually, to have a chat with you about ethics and trust in AI this afternoon. So just a few housekeeping items, maybe. So for questions, please feel free to put your questions in the chat. I think everybody is on mute by default, but please feel free to unmute yourself during the lab portion of today's workshop and ask your questions or continue putting your questions in the chat. So today's workshop, we have designed it to be 1 hour or so, so most of it is presentation, and we're going to have a discussion about ethical AI and trust in AI, but we have dedicated 10 to 15 minutes to hands-on lab. For you to be able to do the labs, you need to have a cloud account, IBM cloud account. And so I believe a link has been already shared with you to get one for free. If you haven't done so, please check the chat right now. I've put the link. The link is cloud.ibm.com. Just go ahead and create a free account for you, for yourself. And it's going to take like 2 minutes or so. It's a very straightforward process. And you can do that during the presentation, so you're prepared and you have access to that account for the hands-on lab. And so yeah, that's it. And so regarding the lab materials, they are uploaded in the box folder. We've shared the link with you also in the chat, so feel free to check them. And yeah, so before we start the workshop, actually, let us introduce ourselves. So my name is Bahareh Atoufi. I am part of data science AI team with IBM as a client technical professional, and I'm working with our financial services sector, helping them leverage AI and machine learning technologies from IBM to add to their competitiveness and solve their day-to-day challenges. I have two colleagues here with me today. Eric and Safura are from our data science elite team, and they're going to introduce themselves and let you know what data science elite team does at IBM, and then we'll continue the presentation. Take it over, guys.
Sure, yeah, thank you, Bahareh. For everyone in the call, welcome. My name is Eric. I'm a data scientist from IBM Data Science Elite Team. Can you move to the next slide? So this workshop is brought to you by IBM and IBM Data Science and AI Elite Team. Safura and I are the members of the team. So we are just a group of AI experts who are passionate in helping organizations applying AI in their business. So we have more than 100 data science operating in 42 countries around the world. Safura and I are local right here in Canada. So our team works side by side with our client to kickstart their data science project. So today, Bahareh is here to talk about OpenScale. OpenScale is the flagship product we use in our project as well. So with respects to the runtime monitoring, fairness, and explainability, and the end-to-end governance for AI system at scale. So to our customer, OpenScale just open up a box of a black box. I think our kind like OpenScale the most is OpenScale allow them to automate AI lifecycle in their business application and ensuring the AI models are always free from bias and can be easily to explain and understood by the business users. After today's workshop, if you have any question or would like to engage with the IBM Data Science Elite team, so feel free to reach out us in email and on LinkedIn, or just follow the link on this page. So to learn about what IBM and what IBM Data Science Elite team are doing in the AI space. So with that, I turn it back over to Bahareh.
Thank you. Great. Thank you, Eric. Okay, so this is our agenda for the next hour. So I'm going to start with the why. Having all of these attention toward ethics and trusted AI, responsible AI, it's important to discuss why suddenly it's attracting all of this attention. And then I'm going to continue with the what. And so, what is the scope? What are the scopes and expectations from ethics when it comes to applying ethics and trust to AI? And then I'm going to continue with the how. So, how can we tackle the challenges associated with this? What's out there to help us? And then we're going to have a hands-on lab. So let me start with the why. And so the why part is actually it's actually easy. We're living in an era where a technology has the highest impact on economy ever. AI is a $15 trillion business due to KPMG recent report. And when you talk with any enterprise in any industry, they'll tell you that they are interested to explore AI. They believe AI can improve their competitiveness. But taking machine learning models into productions is difficult, to the point that 82% of organizations were not successful in adopting it beyond proof of concept. So this is, of course, due to different reasons and challenges in infusing AI in business, but one of the main factors that makes adopting AI difficult for enterprises is due to the non-deterministic nature of machine learning programs and how it's different from traditional software. And that non-deterministic nature speaks to the fact that behavior of your model is based on knowledge that evolves over time. And this fact brings some risks when you take your models to production, which is an unknown or partially known environment, and makes it difficult to trust the model. And that lack of trust has affected the level of, the level to which consumers can trust companies with their personal information. And this is why many organizations are still debating who should take responsibility and accountability when it comes to ethical AI in their organizations. But no matter who's accountable for it, the concept of trust and ethics is real when it comes to using AI in day-to-day life and business. If we accept that AI is going to be a relevant part of our future, it is important to establish the foundations of trust in AI systems. Today, we regularly rely on AI models without having a clear understanding of their capabilities or knowledge or training process. For example, AI-based diagnostic algorithms are assisting in the detection of breast cancer, serving as a second opinion for radiologists. People get on planes that fly on autopilot. They use robotic prosthesis, or even drive semi-autonomous cars nowadays, right? And when we do those things, we are intrinsically expressing trust on the creators of a specific software application. So thinking about all of these concerns raised about trusted AI and ethical AI, we first need to define what we expect and how would define ethics when it comes to incorporating it in our life. The definition of trusted AI and ethics is, of course, very broad, but it almost always involves some common factors like privacy, fairness, inclusion, transparency. So with that broad definition, it's important to see what enterprises think and what matters most to them in addressing AI concerns. So based on a recent report, this is a survey from more than 1,300 companies across around 25 industries. All of these organizations, especially those with mature AI practices, are alert to the risks inherent in the design and use of machine learning and AI technologies. And at the top of these risks, you can see fairness, model interpretability, unexpected outcomes. If you look at these factors that matter most for enterprises, it always comes down to 4 pillars of trust. And I'd like to have a deeper dive in each of these very quickly. So let's start with fairness. And so AI fairness is typically associated with the minimization of bias in AI agents. But what is bias really? I'll give you an example. So imagine a machine learning model that is supposed to identify qualified applicants for a job opening. In a supervised scenario and setting, first you need to train this model with some sample qualified and unqualified applicants' data, so it learns, right? But imagine that all the qualified samples that you provide to the model, aside from their features that shows their qualifications, they're all younger than 25. What happens here, age automatically becomes an obvious indicator of qualification. If that relationship, in our example, age and qualifications, becomes endemic, then by definition, it must be a pattern. And what machine learning algorithms are good at, they're, it's learning patterns. So whether you notice it or not, your machine learning algorithm captures that pattern, learns it, and incorporates it in its decision-making process. And as you can imagine, these desired relationships and patterns in your data are not always societal factors like gender or race or age. It can be any feature in your data really, from specific frequencies in your EEG signal or the duration that the customer has been with your bank. And to show you how much this issue is real, here are several cases in the real life where fairness of our machine learning models went wrong. So you might all have heard about the issue with Apple Card. It's, I believe, the most recent one. So this case was against Apple Cards for giving a user who turned out to be the creator of Ruby on Rails. So he got 20 times the credit limit that his wife got, even though they filed joint tax returns. In another case, a few months earlier, United Health Group became the subject of a probe about a study when there was a study found the company's algorithm favored white patients over black ones. There is another case about Amazon's talent recruitment, which happened in 2015. So their algorithm was biased in favor of men when it came to hiring technical talent, like software developers. And of course, kudos to Amazon team to capture that bias. And it was the main reason was in their data. It was all in their training data, thanks to the tech towards well-known gender imbalance. And so there are many other examples on racial bias and other bias factors out there. So as we try to take advantage of this great technology more and more, the problem of bias models and biased AI and biased data shows more significance in our life. So let's move on to the second factor, which is transparency or explainability. So explainability is really about opening the black box of AI to explain what's behind every decision or prediction and outcome. At the same time, you might have read or been part of the debates about why and to what extent we really need and should have this transparency. We rely on other technologies without really understanding 100% how they're working. We take medications, for example, and based on each person's physiology and 1,000 other factors, they might have different reactions in our body, yet we still take them, although we don't fully understand that reaction, right? And on the other hand, too much transparency can backfire, because then if it's disclosed to wrong users, they can manipulate the model and make it respond, they can make it respond in the, as they desire. So I don't want to start a debate on this. Really, it's beyond the scope of our workshop. But as domains like healthcare and financial sectors, which are highly regulated, look to deploy artificial intelligence and deep learning systems, and this is where questions of accountability and transparency are particularly important. We need proper interpretability and explainability in our algorithms. And also we need to define the scope. So the scope of that is important as well. Aside from the legal and professional considerations that need to be made, there's also an argument that improving explainability is important even more in more ordinary business scenarios. Understanding how an algorithm is actually working can help to better align the activities of data scientists and analysts with the key questions and needs of their organization. So while at least some degrees of explainability might be seen as an obvious factor to improve the trust in AI systems, its implementation is difficult. Transparency often comes at a cost, which is due to the natural disagreement between the explainability of AI models and their accuracy. To increase the accuracy of the outcomes, we use more complex models, and obviously more complex models are harder to explain by a human user. So due to the lack of a tool to help users with explaining the models, users tend to sacrifice or compromise on the accuracy to gain more explainability. Okay, so now let's move on to the third factor, adversarial robustness. And the concept of AI robustness is determined by two underlying factors, really, safety and security. And so safety, regarding safety, an AI system might be fair and explainable, but still unsafe, right? So AI safety is typically associated with some other factors like ability of an AI model to build knowledge that incorporates societal norms and policies and regulations that correspond to well established safe behaviors. And this increasing the safety of AI model is another key element of trusted AI system. And about security, so AI models are highly susceptible to all sorts of attacks, including many based on adversarial AI models, methods. The accuracy of AI models is directly correlated to their vulnerability to small perturbations on the input data set. That relationship is often exploited by malicious actors that can try to alter specific data sets in order to change the behavior of an AI model. And so testing and benchmarking AI models against adversarial attack is key to establish trust in AI systems. And IBM has done a lot of interesting work in that area. So just to show you some examples, these examples are inputs to a neural network that result in an incorrect output from the network. So you see the algorithm can classify the panda or the dog image correctly, but then by adding a very little amount of carefully constructed noise, you can get an image that looks exactly the same to a human, but then the model thinks with 99% confidence that the dog is an ostrich. And so this is another very important factor that's included in trusted AI, and when it comes to trusted AI. And so lastly, it's about lineage and auditability of our AI, which speaks to being able to trace the behavior of your model over time. And so your data keeps changing over time, and so should your models to be able to keep up with changes in your data and the regulations and the business KPIs. And as your models keep changing, lineage of AI models helps us establish trust from a historical perspective. That is really different from what we achieve through fairness, just factoring explainability or robustness alone. Okay, so now we know our AI could go wrong, could get biased, there's challenge in explaining it, but what's out there to help with these? And most importantly, for this workshop, how IBM can help. So, well, on the open source side, and as you know, IBM has a long history in the open source ecosystem, and we're leveraging this to bring tools that help to deploy and operate trusted AI. And so on the open source side, these are 3 Python packages that are available for free for you to leverage. And on adversarial robustness, there is this, so we call these packages AI 360 packages, but they're really 3 separate packages for robustness and fairness and explainability. And so for adversarial robustness, it's supposed to allow rapid crafting and analysis of attack, defense, and detection methods for machine learning models. For fairness 360, it's again an open source library to help detect and remove bias. So it's not only detecting, it's also mitigating the bias for your machine learning models. It's a Python package. It comes with over 70 different fairness metrics, 10 state-of-the-art mitigation algorithms. And on explainability, this AIX 360 toolkit, it's again, it's an open source library to help explain machine learning models, and it includes explainers for models that use image, text, structured, tabular data. And so these are very, very useful packages that you can use. So you can always use open source, but as I mentioned earlier, we've made some proprietary improvement to some of these algorithms in form of a commercial package, which is called Watson OpenScale. And it works with pretty much everything you're working with. And it also provides an API that you can call. But it has a very user-friendly user interface for you. And in the hands-on workshop, you get to play with it and explore it on your own. And so the hands-on lab part is fully dedicated to OpenScale. And so when you look at all of these, so you remember this chart from previous slides. So when you look at all these factors that are important for enterprises when it comes to trust and transparency and ethics in AI, when you look at these, OpenScale can really cover everything that you see here, from bias detection, bias mitigation. It provides explainability. It provides capabilities around detection of model drift and inconsistency between your product environment, production environment, and your training environment. It also provides capabilities around measuring the alignment of your business KPIs with your model performance. So, okay, so before I show you a demo, just another point quickly on OpenScale. And so it's really open by design. That's why I think we call it OpenScale. It's open to different deployments environments, meaning that it does not have any dependency on any of your development or deployment platforms like Watson Studio, machine learning, anything that IBM provides. This means that you can build and deploy your models in AWS and Azure and custom environments, and all the capabilities are still available through OpenScale to monitor the behavior of the models that you've built somewhere else. And so build your models in Jupyter notebooks and deploy them in Docker containers or your Spark cluster. You still can leverage capabilities of OpenScale to monitor that. Okay, so let me show you a quick demo of the environment, and I'm not going to spend too much time on the demo because you get to explore it yourself during the hands-on lab as well. But just to quickly familiarize you with the environment, let me just share my screen again. Yes. Okay. So when you do the lab, you need to go through find the Watson OpenScale in the catalog, and then you need to create a new instance of Watson OpenScale. And then you launch the application and it takes you to the main dashboard of OpenScale. And so this is the main dashboard. As you see, these squares are summaries of monitoring reports that we have on some of these models. So I have brought 3 models, deployed models, to my monitoring dashboard right now. You can easily do that. So you need to configure your deployment and your your dashboard with mentioning what are your machine learning services and deployment environments that you have. So you can just add more services here. And you can choose from Watson Machine Learning, which is by IBM, or a custom environment, or Amazon, or Microsoft. And then after you do the configuration of your environment, and then you can easily add deployed models to your dashboard. So you just select this and bring it to the environment. After you bring them, you need to configure and select and specify some parameters associated with fairness and drift and quality. So as you see, I have brought 3 models here on my dashboard. I have done the configuration for 2 of these. This model, I haven't done the configuration, so there's no monitoring happening at this time for the last model. But so let's have a deeper dive in each of these squares. So for example, this model, let's see what OpenScale tells me about this model when it's monitoring. So in this dashboard, what it tells me, again, this is a summarized, but a little bit more detail about how this monitoring is happening and what's the current result of this monitoring. If there is any alert associated with any of these factors that I'm checking, there is this mark here showing that the value that has been checked and monitored has fallen below the threshold that I've specified in the configuration. I can evaluate manually any of these models. Otherwise, there is hourly automatic evaluation and monitoring happening inside of OpenScale for my models. I can compare different models based on different factors, their quality, their fairness. I can view model information. I can even generate a PDF report for evaluation and monitoring of my model. So let's have a better look at this monitoring that's happening right here. So for example, for fairness, and let me do it for the past 3 months for this model. So I've brought this model and it's been it's being monitored for less than 3 months here in this environment. And so as you can see, I have 2 factors that I'm monitoring, 2 factors for fairness. However, I can add more factors here. So depending on what features I have in my data, I can add or remove factors here. For each of these factors, I can specify a threshold here. So as you can see, I have specified a threshold of 98% for my fairness of around 6, which means if the fairness of my model drops below 98%, I will receive an alert. And so again, let's have a deeper dive here. What it tells. So at any given time, any monitoring that has happened hourly, when I click on those on the chart, it takes me to a more detailed chart. And this chart tells me if there is a bias and why it has detected the bias. So the bias has been minimal here, but as you can see, it tells me for 2 groups of female and male people that I have in my data, there are 20% that are associated as risky applicants. So this model is a credit risk prediction model. So 20% of my female applicants have been associated with risk or labeled as risky as the outcome of this prediction, while 19% of my male applicants have been associated with risk. And so this difference between these is a red flag for for OpenScale to do further exploration and for me to have a closer look at how my model is behaving. And so if I want to have a closer look at transactions, this even takes me to single transactions that are responsible for that bias. So if I filter to bias transactions, these are the transactions that need to be altered. And OpenScale has identified some fairness problem associated with the results for each of these transactions. Some of them is kept original, and some of them has been altered as risk has been associated regarding bias. And so you don't need to, so the an important thing here is that OpenScale does not touch your model really. It offers a debiased version of the result to you so that you can change the outcome considering what OpenScale has found and while monitoring your model. Okay, so another thing I wanted to show you is drift. So drift detection and monitoring inconsistency also is included among the capabilities of OpenScale. What it means is that so over time, when you're monitoring your model, if the accuracy of your model, and you can define this accuracy and you can choose these factors, but if the accuracy of your model drops below a predefined threshold, so threshold is yeah. So if it drops below this threshold for any of these monitorings, it gives you an alert. Also, it gives you the transactions that are responsible for that drop in accuracy, classifies them based on different features, and you can have a closer look at each of these transactions. So why this transaction has caused this drop in my accuracy? Was it because the values has been the values of the attributes have been very different from what my model has seen and trained with, and it comes up with some reasoning behind this drop in accuracy, and it comes up with some recommendations in natural language for you. So which features to look into if you're looking at you know, this specific transaction. And so as somebody who monitors the models, you can communicate this with your data science team who's behind developing this model, and and you can have a closer look at some of these features who are responsible for this specific drop or in the accuracy or for this specific transaction. And so another thing I wanted to quickly mention here is about explainability. So we talked about fairness, quality, and drift. And so how do you exactly explain any of these? And so to mention about explainability, so I showed you how you can check the transactions, but you can actually explain each of these transactions. And this, when it comes to explainability, there are two levels of explainability that OpenScale provides. One is the local explainability, or the Lime explainability, which is basically a feature importance. So you can see it categorizes the features, and so you can see how much each feature is contributing to the final outcome of your model. And the other level of explainability, which is called contrastive explainability, is also provided in OpenScale. And so what it means, the contrastive explainability, OpenScale, while monitoring your model, it monitors all the transactions that and you know, the payloads and scorings that are happening between your applications and the models that are there, right? And so when it's during this monitoring, to provide this contrastive explainability, it looks at the vicinity of each data point. So each transaction, each data that you send and request a score from your model, when you see it as a data point, when you change the attributes, the value of attributes a little bit, you can check the vicinity of that data point in the feature space. And so what OpenScale does, it studies that those small changes around in the neighborhood of that data point, and gives you these two pieces of information. So what are the minimum changes for you to change the final outcome. So for example, in this case, if you have realized that this person, this applicant, is no risky and you can give them the credit they have requested, what are the minimum changes that can change that outcome to risk? And what are the maximum changes that you're allowed to have in that data point to keep the outcome the same? And so these are important features, important pieces of information when you're explaining the outcome of your prediction. So for example, if in this case, if the applicant says, I am partially approved for this credit application, what can I do to become approved? What can I do to get the approval for that? You can check. So this is a way to look at the possibilities here and say, okay, so these are the most important factors contributing to rejecting your application or partially approving your application. But if you make these changes, you can get approved. So these are some important information that you can get by explaining the behavior of your model and how it's making these decisions. Okay, so let me go back to the slides quickly. And I believe I'm sharing my screen. Yeah, here. Yeah, so what we saw was OpenScale, and so I showed you the dashboard, some of the configurations, and some of the capabilities around drift and explainability and bias, and you get to explore them all during a hands-on lab. But just quickly on, this is another capability embedded in OpenScale. This is in public beta, so it's not fully there yet, but this is about alignment of your business KPIs with performance of your models. And this is important for you to understand how your models are actually contributing to your business APIs. And this is another capability embedded in the dashboard or in the solution, which allows you to see that alignment and that correlation closely. Okay, so we also wanted to share with you about some of the use cases and how some of our clients are actually leveraging this tool. And our data science elite team has been working with many clients in many of our Watson solutions, and OpenScale is one of them. And so I asked Safura to go over this use case and let you know more about how this collaboration project happened.
Okay, thank you, Bahareh. Hi, everyone. My name is Safura, and I'm also data scientist at Data Science Elite Team. And I usually work with clients by driving them on their AI journey and implementing various growth opportunities by building machine learning models and deep learning models. Recently, however, we worked with a big retail company in US, which already had their own data science team, and they have already built and deployed many models on their cloud environment on Azure. However, the client's data science team was struggling with another issue. They were struggling with managing and understanding their models. And one of the models they had was around hiring process. So they wanted to proactively mitigate the bias in hiring process. And this actually was one of the requirements by their business and legal departments, that they include transparency into the decisions made by machine learning algorithms at a faster rate in production. So in this project, there were two goals. First, accelerating identification of any bias in hiring and explaining decisions made by AI models. And second, operationalizing AI governance across the whole organization and getting more people on board with AI ops so that their productivity goes up. And over the course of 6-week engagement, we help the client to understand first their data better, second, define what is favorable and unfavorable outcome, third, proactively monitor the health and fairness in the client's hiring system by leveraging OpenScale. Overall, as a result of this engagement, the team not only learned how to track their performance of their models real time in production. But eventually, they also decided to integrate OpenScale as part of their hiring helper application. And the monitoring and explanations allowed our client to inspect, understand, and correct decisions, maintain its commitment as a fair employer, and maintain fairness for each of its candidates and new employees. So that's just a bit of information. I can't share a lot of details on this use case, but if you have more questions, feel free to ask. I'll try to answer to them. Thank you.
Thank you very much, Safura. And so we have this use case and many other use cases. So some of our use cases are unfortunately not public, so we're not allowed to disclose much details about them. But we have some public use cases on our website as well, and I encourage you to check out those use cases. They might apply to your industry and your use cases as well. Okay, so we have around, I think, 15 minutes or a little bit over 15 minutes for doing the workshop, which should be enough. So what we have in mind for you to do the workshop is basically the first lab, which is the automated configuration. So when you do that lab, and so the lab material and the instruction, everything is in the box folder, which is uploaded, and the link is already shared with you in the chat. So feel free to check out that link. And so feel free to start the first lab. Initial setup lab is required for doing this, the lab 02. So if you would like to do everything, all the configurations manually, feel free to do that. And for that, you need to do some further setup in your account, and you need to create an instance of Watson Studio first to bring your model in and run it and deploy it in that environment. And then you can call it from OpenScale and do the configurations manually. But Lab 01 doesn't need further setup. And so you can just go ahead as long as you have an IBM cloud account, just go ahead and start Lab 01. And after it automatically does a configuration for you, you can explore the model on your own pace and see all the features, capabilities that I showed in the demo. And also, if you have any questions, please put them in the chat or unmute yourself, whichever you're more comfortable with. Okay, so there are questions in the chat. So Cynthia asked if you should create an account if you don't already have one. Yes, please create an IBM account. It takes a couple minutes for you to create one. It's very straightforward. Just go to cloud.ibm.com to create a free account. And the question about the links. So all the links are, I think, at the top of the chat box. I can share them again. So if you can confirm that you can, yes, Safura, thank you, Safura, you've shared the link with them as well. Okay, so everyone should have access to the link. Okay, so there is an issue with access to the lab files. Can you please confirm if anybody has been able to access those? If not,
well, I did not open the slides. I mean, I'm still in the account. I just opened that 01 PDF file.
Okay.
The OpenScale lab. I guess I've not started. I guess I've not started anything in terms of.
Okay. Okay. Thank you very much for confirming. But you have access to the lab files.
Yes.
Okay. Thank you very much. Okay. So that's great.
Should I actually, I went into the lab folder file. Which one should I open, the credit files or the what file? You know what, do you think I should go to the dashboard and start over or something?
So have you created, so you have a cloud account and you have created your instance of Watson OpenScale?
Probably
no, not yet. Okay, so go to Lab 01.
Okay,
and,
okay.
Yeah, so Lab 01 is the more straightforward lab. So there are two labs that you can choose to do. Lab 01 does the configuration for you. So all the configuration happens automatically, and you get to see the steps, and then it creates the instance for you, it brings the deployed model for you automatically to OpenScale. And so you can just click on it and explore it.
Okay.
Lab 02 is the one that needs you to do everything, all the configuration manually. And to do that, you need to do further setups, which is in Lab 00. So Lab 01 is independent from Lab 02. Okay, and there was some problem with accessing the report. I just downloaded it separately because the link I provided earlier was an internal link. I apologize for that. And so the link is now uploaded in the box folder, so you can access it through this link. Okay, correct. Thank you for confirming that the link works. Perfect. So I assume that everybody's, or at least some people are doing Lab 01, and it will take you 5-6 minutes to finish that lab. Just wanted to mention that your cloud account that you created for this workshop, it doesn't expire. So you're gonna have that. And then your instance of Watson OpenScale that you have created on IBM Cloud, if that stays inactive, or if you don't open it and work with it in 30 days, it will be deleted from your cloud account, and then you have to create a new one. But before it disappears from your account, you will receive an alert in your and I guess they email you automatically that they are deleting your instance from cloud because it has been inactive for over 30 days or so. And so you can just do some activities in that to keep it active, or you can just, if it's deleted, you can just create a new one anytime you'd like. Okay, and you will have access to lab materials, I think by the end of the month. And I can extend that for you, but you can download everything and just keep it on your computer as well. And you can do that anytime that you'd like. And yeah, so while doing the lab, because we have only 4 minutes till the end of the session, if you have any questions, please let us know. If you're planning to do the labs later, again, please reach out to us if you have any questions when you do them. If you have any questions regarding OpenScale, about any of IBM products, about Watson, any of that, please don't hesitate to contact us, and we'd be more than happy to help you with those.
Okay, I'm all right. Still working.
Okay, so are you, Cynthia? Are you doing Lab 01?
Yes, I believe I clicked right. I'm at the launch application. Well, I already launched the application, and then it's configuring.
Yes. Okay. So yeah, you have to be patient with it while it's doing all the configurations, and then it gives you a prepared monitored model, a model that is being monitored, and then you can check all the parameters, all the values, everything yourself.
Okay.
And it's the same model that I showed in the demo, the credit risk model, and so you already have some ideas about what the model is.
Okay.
Yeah.
Thank you so much for the great presentation and the demo.
My pleasure. Thank you for your help and support for us. And thank you, TMLS, for giving us this opportunity to have this workshop to talk about trusted AI, ethics in AI, and introduce OpenScale.
Absolutely, no worries at all. What we can do is after the summit, so perhaps later this week, we can send out a mail to everybody at the workshop. So if you just want to share all the links, plus also we'll be, as we are recording the videos, they'll also be shared as well too. So we can send that with your permission. We can send that out to all of the workshop attendees as well.
That's wonderful. Thank you very much, Faris.
Cool.
Okay, so we have a couple more minutes. Any questions about what you saw, about OpenScale, about the capabilities, anything that you'd like to know, let us know, and I'm happy to help.
Did you mention that the attendees will have access until the end of the month, you said?
Yes, and I can extend that, but they can easily download the files. I mean, the volume is not very heavy. There are only 3 files, and they're one of them is a PDF and 2 PowerPoints with the instructions and everything. So yeah, you can download, and you have access to your instance on cloud, IBM Cloud. So you can just try it anytime that you like.
Perfect, cool.
Yeah, yeah.
And also to add on, if you do the lab too, you can also try your own models as well. If you have some other models deployed, classification or regression models, deployed maybe on any cloud or on Kubernetes, you can try to check like how fair or what is the quality of your model as well.
Mm-hmm. Yeah, that's a great idea. Thanks, Safura.
Yeah, that's going to be very useful for practitioners who already have built their models. So I think it's going to be very useful. Sure.
And
yeah, exactly.
No cost with White Plan, so you can, I guess, upload up to 5 models.
Yeah.
Like up to 5
Yeah.
models.
Nice.
Yeah.
All right, everybody. I just wanted to say once again, thank you so much for attending this workshop, and also thank you to the IBM team. Once again, we will share all the recording and the resources just after the summit, and I look forward to hosting you all once again.
All right. Thank you very much, everyone. Thank you, Faris.
Thank you very much, guys. Thank you.